especially for us, especially for me. And I must add to some of the things that I mentioned yesterday, and actually what Virgilio said, that when he mentions the name of Jim and Arun, and people suddenly become very friendly. I would like to add that it's almost like a badge of honor for me to call Arun and Jim friends. And I do travel around the world, and when I travel around the world, I meet people, and I caught myself, and I need to publicly say that, to tell people, you know, Arun and Jim are my friends. And then you can see that people really show more respect for you when it happens. So, so let's move on. Okay. I didn't talk about it last night, but I think it's good to actually put it on the paper. The upper quote, and this is actually became one of my favorite quotes, and I have been using it and will be using it going forward. Because very often we forget that really what makes progress and makes things happen. And this is a work that Jim, Arun, Stan, Mark, and all the other, lots of people here in the room, Phil and the others did, was really a result of the teamwork. But I couldn't resist to put these couple of paintings here. And you probably know, but just to emphasize how well-rounded individuals Jim and Arun are. Not only the leaders in the industry related to protection and phasers, but really excellent artists, both Jim and Arun. And I have actually two paintings from Arun here. And so they're also people to be fun people to be around with. That's I think very important to acknowledge as well. Of course, since both Arun and Jim work for a university, I just have to have one equation here. I imagined the presentation without an equation, and I know Jim and I had some discussions on sometimes how many equations you should have in the presentation, so I learned a lot from Jim on this. But I'm just joking here. Actually, the reason I have this equation here is to, and you can see it's actually connected with these relays here on the right side. That work that Jim and Arun have done is actually implemented in every single, I would say, every single product of a major manufacturer in the world. And we're not talking just about PMUs. So we are now kind of focusing a little bit, and it's good, because PMUs are the in thing and all this stuff. But even before PMUs, work that was done when we were just introducing microprocessor relays in the industry and so on, DFT and phasor calculations and so on, ideas that came from Arun and Jim were the ones that were implemented. I think that's something that we really need to acknowledge very strongly. Okay. So moving on, you've seen the picture. It's just I wanted to have that effect. You see this, you see that, you see this, you see that. So I don't know. Of course, the idea being how many more PMUs we have due to the team effort. This is actually I like to show this slide for a couple of reasons. Firstly, it's the roadmap that we did. Actually, originally it was done through California Energy Commission CIE peer program. It helped from Phil as well and Joe. And we developed that because there was a question at that time, what's the value of PMUs? So everybody was saying that's a great technology, all is good, but how can you really use it? So we did work at that time, so-called business case study related to PMUs. So we did a study with a focus on creating a roadmap. What needs to be done to deploy the technology? And again, the focus was multiple facets. It was you have one related to business, the architecture, the technology itself, and the applications as the really driver to make it happen. So the other aspect what I want to emphasize is this was in 2006. You guys can now look into this and see how realistic it was at that time to propose this type of roadmap. Or let me put it that way, 7 years later, has these things happened? Or how close we were at that time to predict was general performance of data, then it's for control application, it's quite some challenge. So then you really want to make sure that this roadmap is done in this way. So I'm not going to go into the details of this roadmap because it would take my, not just 15 minutes, but half an hour to do it. But at that time, in 2006, we thought this would be the application. Angle frequency monitoring, post-mortem analysis, voltage stability monitoring, and so on. And I believe that when we look now at all the projects, SGIG projects, we actually achieved the targets, and we were actually somewhere here. So I think that's, actually I think we all should be very proud of this fact. Okay? And that was actually the updated roadmap, and that's also interesting to see. Here we have a number of applications. We see a number of applications growing quite a bit, and understanding how we can utilize the technology. Okay? This is just an example with SGIG projects where we see what's happening now in the industry, where they are, tying again back to that roadmap. If you look now with 3-year deployment, conservative to aggressive, related to number of PMUs, and related to applications. The basic applications, monitoring visualization outside of the control room, visualization inside the control room functions, some real-time applications, and then really big bang, where we are now. And I want to say this is not a scientific approach. It was really an approach just to kind of see where we are as industry. And we see this is probably, you can guess, primarily ISOs. And we have a large number of PMUs, but not too many applications. Here we have companies like PG&E that still has a number of PMUs, but is also focusing on applications. And Vahid will be talking more about exactly what those applications are and how it all fits together. So moving forward, it's also a little bit older slide. And I think this is good to show the progression. The slide, I think, we put it together maybe 3 years ago. Looked into what was before, what is now. But I think let's put some focus here on 2014 and 2018. Expectations are now that next year you'll have standard feature in relays, DFR, controllers, equipment monitors. I think we're actually there. On major interconnections, we are there. Some distribution PMUs. And we'll talk about it more about distribution, so let me skip that now. Improved communication infrastructure, including control, standard software tools included in EMS and SCADA. And we have vendors here that have included it in EMS and SCADA solutions. And then interoperability standards deployed. So Ken, Mark, 2014. Now, I'm joking now because, of course, we are still moving forward with 37.118.1, finalization of the, or update of the standards, so let's not go there now. But the bottom line is that actually we did develop quite some standards and guides, thanks to, again, to this community here. So I believe, yes, we are there. Interoperability standards are deployed. 2014, I think, will be really in a good shape. 2018, thousands of PMUs worldwide, higher data rates, and so on, fully in distribution. I must tell you, a few years ago, I thought fully distribution 2018. If you look now what's happening in distribution, and there is still lots of work, Jim and Arun. I'm sorry, but you really have to help us going forward. I don't buy that retirement stuff, just to let you know. Distribution is booming, There are really a number of utilities now that are implementing, deploying PMUs in distribution. Actually, I just had a recent discussion again in California. Said, Damir, let's do the business case now, like the one we did for the large PMUs, let's do it for micro PMUs now, for the deployment in distribution. But look at these applications. And again, it's not about today talking about applications, but if you just glance through these, see the list. Isn't that amazing? I must tell you, I'll admit, 2006, I didn't really expect this would happen. So I was blind. But I'm so glad that it's happening. So, okay, let me move forward. I think Phil gave a really good overview, so it makes my life much easier here. But just to emphasize that after the 2003-2006 US and European outage in 2006, US in 2003, that was really the catalyst to move things forward. We saw the recommendation 12A, application of synchronized recording devices in power plants and substations. Very similar, 2006 disturbance. Of course, that's kind of the bad thing in life. Europeans had to have that disturbance to realize that. They could have, of course, read the report up, the one, and said, why don't we implement those devices before 2006 so we don't have to write the same report? And of course, the report is written here. You have to put information on it here to observe in real time the actual state and so on. So again, real time, observability, situational awareness, and all these things. And again, this is 2006. I have actually for me at least, interesting story. I was in Croatia, there was a CIGRE Croatia meeting, and I was talking about PMUs. So the blackout happened on Sunday. And we had a talk on Monday morning. And Walter Settinger was giving a talk. I gave a talk, and he was from SwissGrid. He was giving a talk next. So I gave a talk on importance of PMUs, so he comes and shows this. It was less than 24 hours after the blackout. He was able to get the data and say, see now, just with few PMUs, we were able to do this. To understand how systems separated, you can see here, and so on. So moving on, India. Again, India is now deploying 1,700 PMUs. And we probably all know that without Dr. Phadke and Dr. Thorp, and Dr. Phadke was advising Indian organizations like Power Grid India to pay attention to the technology. And key findings, better visualization and planning of corrective actions, deployment of wider and monitoring, protection, and control systems. Okay? So I turn it over to Vahid.
Thank you, Damir. Thank you, Matthew, for the invitation. I'm with Pacific Gas and Electric. Before I get into my presentation, I wanted to show you who they really are, and it is truly a privilege for me to be here. The key thing that Damir was trying to highlight, and he brought up the 2003 to 2006, I want to bring up a little bit closer. 1996, there were a lot of lessons learned. Phil touched on it. 2003, that's a lot more than 3 years. I can tell you the number one thing was that side has the stability issues. I have a mesh network, it'll never happen to me. So that's, I was in a lot of meetings. You can, aside from the fact that and power system is a very large machine, and making changes in this power system, as you hear from particular utilities, it's not a simple thing. But I think between 96 and 2003 that we did have a lot of room, certainly more than 3 years. The picture in front of you is the event we hold at Pacific Gas and Electric once a year, 3 days, and oftentimes I have to plead to Jim and Arun, would you please join us? They truly are very enlightening. Okay, a little bit about 1965 and some of the lessons, of course, that followed from several of these. Right? These events that we are trying to describe are not events of subcycle natures. These events are phenomena that are a series of contingencies that occur. Something breaks, something else follows it. There is generally time, as we call it, on your side. Sometimes you only get 11 minutes, as it was September 8th of 2011. Sometimes you get 4.5 hours. Okay, but time is on your side. So within reasons, we can design systems with a lot of intelligence around it. Okay, so what you're seeing before you, of course, on the left side is the 1965 event, November 9th. But the bottom line is the consequences is blackouts. And the sequence, it may be a little bit different. I used to call it, for about 10 or 12 years, I used to call it the influential tree. Because no matter what, we were looking for that silver bullet that caused that problem. Well, these are really a chain of events that happen, not one single phenomenon. So that day may have been a tree. In 1994 was a snowstorm and icing on the conductor, so it's not always a tree. So. A little bit about what we did with help actually from both Jim Thorp and Arun Phadke, Stan Horowitz, and Mark Adamiak. A number of our working group members are here today, so I see Eric sitting over there quietly. So we put together a survey of industry practices and experiences. And what you're seeing on the bottom, well, this shows you the percentage of participation at the time. And this was a backup to the second survey. The first one was done by Laurent, I think. Miroslav, he was the vice chair, so I'm blaming it on Miroslav. But we had a survey in 1999. So this was a pretty good timing. We started this survey about 2006. And by 2009, we had the reports, and we actually make a lot of comparisons between the two surveys. And you can see the denomination of where the problems are. Okay, we had 1,000 respondents, but out of the applications and where they see it, you can see it says voltage instability, frequency instability, small angle instability. So you can see the percentages. And the way this thing is laid out is what we call normal day-to-day operating, okay, versus system constraints and congestions. Shortly after the September 8th, shortly, I mean immediately, a few days after the September 8th of 2011, FERC published a questionnaire for at least for the Western power system utilities, if you want to call it, and what are you doing with angles? How have you been dealing with angles? What is your knowledge of the angles? How do you see your neighboring systems? And also, what are the tools you're putting in place moving forward? So in a summary, and I have a different version of this because I also have to teach NERC classes for real-time operations. But in summary, trying to put this in one slide, you have three major high-level questions from that survey that FERC had issued. One was angular separation, ability to determine in real time the standing angles that would resolve following major transmission line outages. Second one was real-time external visibility. Okay, how much information or what do you see from your neighboring systems? And you see the lack of adequate awareness of external contingencies. Real-time tools, without having tools in place to determine the phase angle difference. So a lot of this particular slide was about angular separations. And of course, as you know, PMUs help us quite a bit. So I turned this into a lessons learned, and I extracted roughly about 8 slides, or I created 8 slides from this. Then amazingly, I go back to the 2003 report to do the same thing, and guess what? Got about 7 slides, very similar. I can assure you, if I go to the Europeans, because I write some of those reports or review them, I see the same similarities. I do have the slides from some of my speeches you have seen. there are well over 145 recommendations. If we could do a fraction of those, I think we can minimize or arrest the blackouts. I use the word arrest as opposed to prevent. Prevent is it's very, very restrictive word in this case, but it's like, to me, it's very similar to saying, can you prevent a heart attack? You can minimize it, you can arrest it, you can prevent quite a bit of prevention. So widespread blackouts are symptoms of strategies for grid management, however you want to read that, right? How do we operate the system, right? Analysis of disturbances, they show definitely a lot of common threads, right? Learn from the past, blackout propagation. Restoration times could be reduced, right? Use of smart grid for situational awareness, not possible to avoid multiple contingency-initiated blackouts. This is a very large machine, very well interconnected, well operated. It does operate as a pulse, at least in my view, and it's very easy to touch the artery of this pulse somewhere and have domino effect other places. So therefore, the more diagnostics we have in place, the better off we are. Okay, so some of the tools you're starting to see look and feel, and I'll go a little bit into details. Of course, here you can see a tabular format in the center of this diagram. Here we're trying to show the angular differences, and this is, of course, a single line. So a real-time operator or dispatchers at a given time, they have the text version, as I call it, which is the tabular version. They can see the alarms. It's turning red. That's, by the way, voltage violation, just so you know. So how do we create these? We'll get to those in a minute. So angular separation. So what's next? That's what I was asked to come in and tell you what's next. What's next, Arun? Jim? Those are the two people that we're going to ask, right? Stan, are you going to give us a little hand here somewhere? Okay, so how do I achieve, of course, Damir mentioned distribution. Just last week, I had the pleasure of hosting roughly 18 ASEAN different representatives. These are people from Vietnam, Laos, Philippines. There's a number of countries. Their number one challenge, of course, is these are developing countries, if you want to call it. They are focused on distribution. That's the first challenge. So long before I get into problems on the transmission, I got distribution problems. So a lot of their focus was on what can we do with the PMUs on distribution. So that truly is an issue for. And naturally, I get the same type of a question here from the North American countries. Okay, how to achieve more benefits from the investment, more system integration, more customer focus. Okay, what does it mean to the customers? Damir talked about the study that was done in 2006 as part of the California Energy Commission. We really spent a lot of time in there. We had representatives from leadership of the companies. We had representatives from the governments, both state and federal. We had the technical subject matter experts. We really tried to wet this. And I thought it was a really good, and thanks to Damir, he actually didn't want to just limit the discussions to the western part of the United States or North America. So there was a lot of discussion between Damir and I. Who are we going to bring from the East Coast? Who are we going to bring from Texas? Let's go ahead and bring these people in. We hosted that at PG&E and I think a couple of sites in Southern California, Edison. It turned out to be a better wide area situational awareness. Again, situational awareness, operational applications. These are some of the applications that PMUs are delivering. Situational awareness. And situational awareness has a definition. You can see that. Abnormal angles and voltages, overloads, real-time voltage instability indicator. Where are you in terms of reactive margins? These are actual tools that are that have been generated as a result of the study that Damir mentioned, and subsequently the support from the DOE in terms of the investment grants. Volt angle visualization. We are not teaching volt angle terminologies to the dispatchers, real-time operation. So these are real. I started with some of the lessons learned at FERC. We had a lot of arguments amongst my team. Shut the door and say, hey, if one of you has one of those degrees that says Ph.D., let's figure this thing out. We should be able to figure it out. So if there are additional angular, please let us know. But the three that we have come up with is the relative angle, the volt angle difference, and the volt angle rate of change. Okay, so the relative angle is respect to reference to two different measurement points. Volt angle difference of a pair nodes. Okay, that's generally for real-time operations. Two ends of the line is really a good example to use. And of course, the rate of change of angle. Now, the first one, I see a lot of times on the past, particularly the past 12 months, maybe a little bit less, 9 months. I see a lot of our operational people, and when I say our, it's not Pacific Gas and Electric. It's a much broader. When I talk about our, I'm talking about from Canada to Mexico. So we have a large disturbances, we have large excursions, and the immediate reaction is they pick up, including me, I guess, we pick up the two angles or the two corners and we're trying to figure out the angular difference. That is wonderful, as long as you know that the measurements you're receiving are extremely precise. Okay? This technology, they didn't tell us when they told us what a great thing it is. It's really an extremely precise technology. You must have a very, very tight window, okay, in order to, so if you're, the point being is conformance testing. The devices need to all, particularly when you're going between different manufacturers. Some of the additional tools, real-time voltage instability. We talk about PMUs. We are not installing PMU at every terminal. This is not your SCADA system. You have a much smaller footprint in terms of PMUs. So what happens if a PMU is out of service? Can I make the same use of the same tools when that PMU is out? Now you're talking real-time operation. People are relying on this data. Can I substitute a different PMU for that missing PMU for whatever reason, let's say maintenance? Couldn't go without resisting, making sure that Phil is acknowledged for all his hard work. This is the facility we use. We call it proof of concept facility. Many of you have visited, and if you have not, please join us. But this was in response to a FERC question. As part of the project, FERC had asked the question, how, knowing, this is 2008, 2009, knowing that the technology is, even though the products may be solid, the technology and the, as a whole is still in the state of flux, how do you manage risk? Well, this was the answer, the proof of concept facility. It's very large scale, it has a lot of capabilities. As a result of the proof of concept facility, you can see we've managed to collaborate with a lot of different industry participants. You can see IEC, SGIP, NIST, NASP, and the DOE, and the work that's taken place and the standards that have been released or that been worked on, quite significant. Lessons learned, in the interest of time, I just show it to you. There's a lot more lessons learned on this. Again, this is focused with standards. This is not focused with lessons learned for a power company. We get into next step, which is data extent. Okay, you can see that this one is WECC. In this case, you have the Eastern interconnection. So the data in one case was coming in to WISP, okay? And WISP is a recipient of the data. In this case, you have the RCs. This is basically, these are all the variety of tools you have, geospatial, as well as, like I mentioned, signal lines. Couldn't resist having to invite you to join us for 2014. We are in San Francisco. For those of you in the West Coast, there is travel required. Okay. And last but not least, you think that the life is a lot brighter with Jim and all of them. Thank you.
I just want to add that without people like Vahid or Matt Gardner and other people that are in the utilities champions, because at the end of the day, nothing happens in life without champions. So it's so good to see there are people like Vahid and Matt that are championing this technology and really making our industry better and supply the energy more reliable. The last thing, Matt is telling me time's up. He's been embarrassed now. Last thing I do want to add, and that's why I show these paintings there, because I see both Arun and Jim as Renaissance people. Think about Leonardo da Vinci. He was an artist and a scientist. I'll turn a little bit around. Arun and Jim are scientists and artists. So.